Hi, Mr. Wright here, and welcome to this film in which I'll walk you through the IGCSE questions on surface area and volume. Now, be warned, the last of these involves finding the surface area of a frustum, which involves finding the sloped height of a square-based pyramid. Now, finding the sloped height of a square-based pyramid comes up now and again in IGCSE and GCSE papers, and it's well worth getting your head around how to do that. So have a careful watch of that last film in particular. Watch the film, try the question without the film, have another go, and let me know if you've got any questions or you'd like any more practice on the concepts in that fourth question, or indeed if you'd like a hand or more practice on any of these questions. Okay, let's get on with the maths. Question 14. Here is a triangular prism. Let's just pause and have a look. Yeah, I agree. It's a triangular prism. It's got a triangle at each end, doesn't it? Here you are. There, for example. Okay. AD is 53. That's marked on the diagram. DF is 28. Angle FDE is 30. So all of that's marked on the diagram. Work out the volume of the prism. Give your answer correct to the nearest whole number. Right, well, if I want to know the volume of the prism, I'm going to need to know the area of the end. So here's the end. It's a right angled triangle. This length is 28. 28 here. That's DFE. That angle is 30. So to work out the area of this right angled triangle, I'm going to need to know its base, which I'll call x, and I'll need to know its height, which I'll call y. How am I going to find x? So I could use trigonometry, couldn't I? It's cos, isn't it? There we go. So x is the adjacent. So x is going to be cos 30 times by the hypotenuse times by 28. Right, so on my calculator, cos 30 equals times by 28 equals, gives me 24.2487. 24.2487. Okay, so that's x. I'm deliberately using a whole load of decimal places because I'll round my final answer later. Now, how shall I find y? Well, now I know that x is 24.2487. I could use trigonometry, couldn't I? So y will be the square root of the hypotenuse squared, 28 squared, minus x squared, which is 24.2487, etc. squared. Right, so I'm going to square x, okay, which is 588. So it's going to be 28 squared minus 588, and that gives me the square root of 196. So y is 14. Okay, so now I think I can find the area of that. Here we go, I can find the area of the end now. So the area of DEF is the base, 24.2487 times the height divided by 2. Okay, so that is 24.287 and so on, times by 14 equals, divided by 2 equals. So I get an area of 169.7409. That'll do. Now, I need to find the volume, don't I? So the volume is going to be the area, 169, so on, times by this length here, isn't it? CD, or AF, I guess. I'm going to say AF, because I'm going to find AF by looking at this right angled triangle here, from A to D to F to A. Let's just draw that triangle there. So I'm going to put F down here. So that's F, that's A, and that's D. And you've got a right angle at F, haven't I? Okay. A to D. A to D is what I'm trying to... A to D is 53. That's okay. And F to D is 28. And what I'm really after is AF. So I'll call that little a. So little a is going to be the square root of 53 squared minus 28 squared. Okay, square root of 53 squared minus 28 squared equals 45. So the area, so this length here is 45, or that length there is 45. So the area of my prism, the volume of my prism is going to be 169.7 and so on, times by 45. Okay, so it was 169.74 and so on times by 45 equals, and that gives me on my calculator 7638.3 and so on. So to the nearest whole number, 7,638 cubic centimeters. Question 15. The diagram shows a solid triangular prism. Yes, I agree, that is a solid triangular prism. Work out the total surface area of the triangular prism. Give your answer correct to 3 significant figures. So the total surface area, so the area of all the faces added together. Let's have a think about the end first, shall we? 4.8 and 3.6. So the area of that is 4.8 times 3.6 divided by 2. So 4.8 times 3.6 equals, divided by 2 equals, and actually I've got 2 of those, haven't I? Because I've got the other end as well. So actually, I might as well on my calculator just have done 4.8 times 3.6, mightn't I really? 4.8 times 3.6 rather than halving it and doubling it. So that gives me 432 over 25. So that's the 2 ends done. Now I've got a bottom. I've got a rectangle on the bottom. Okay, 3.6 by 7. 7 times 3.6 equals, 7 times 3.6 equals 126 over 5. So I've done the ends, I've done the bottom, I've got the side. Now the side is a rectangle as well, isn't it? This is the back here, I'm talking about this side here, okay? Right, so what does that measure? 4.8 by 7, okay? 7 times 4.8. 7 times 4.8 is 168 over 5. Okay, and now I've just got the rectangle to do here, which happens to be on a slope. And that rectangle there measures 6 by 7. 6 sevens are 42. So now, if I add up this, 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 and this, and put my answers correct to 3 significant figures, I'll have the answer that they're looking for. So 432 over 25 plus 126 over 126 over 5 plus 168 over 5 plus 42 gives me an answer of 118.08, and they want the answer to 3 significant figures, so my answer is 118 square centimeters. Question 16. Given that the surface area of a sphere is that, wait a minute, the formula for the surface area of a sphere, 4 pi r squared, so it's telling us that 4 pi r squared is equal to 49 pi. Okay, given that the surface area of the sphere is that, find the volume of the sphere. Now, what's the formula for the volume of a sphere? The formula for the volume of a sphere is 4/3 pi r cubed. So we might want that in a minute. Given that the surface area of the sphere is 49 pi, so that gives me that equation. Let's have a look at that equation. I think we can use this equation to find the radius. Divide both sides by pi gives me 4r squared equals 49. Divide both sides by 4. R squared is 49 over 4. So r is the square root of 49 over 4, 7 over 2, or 3.5. So the radius is 3.5 centimeters, and now it wants me to find the volume of the sphere. Well, I can do that using this formula. Now I know the radius. Volume is 4/3 times pi times 3.5 cubed. Give your answers to the nearest integer. Okay, so on my calculator, 4/3 times pi times 3.5 cubed gives me an answer of 343 over 6 pi. Use the S to D button. Gives me 179.594 and so on. So to the nearest integer, 180. That's my answer to question 16. Question 16. Given that the surface area of a sphere is that, wait a minute, the formula for the surface area of a sphere, 4 pi r squared. So it's telling us that 4 pi r squared is equal to 49 pi. Okay. Given that the surface area of the sphere is that, find the volume of the sphere. Now, what's the formula for the volume of a sphere? The formula for the volume of a sphere is 4/3 pi r cubed. So we might want that in a minute. Given that the surface area of the sphere is 49 pi, so that gives me that equation. Let's have a look at that equation. I think we can use this equation to find the radius. Divide both sides by pi gives me 4r squared equals 49. Divide both sides by 4. R squared is 49 over 4. So r is the square root of 49 over 4, 7 over 2, or 3.5. So the radius is 3.5 centimeters, and now it wants me to find the volume of the sphere. Well, I can do that using this formula. Now I know the radius. Volume is 4/3 times pi times 3.5 cubed. Give your answers to the nearest integer. Okay, so on my calculator, 4/3 times pi times 3.5 cubed gives me an answer of 343 over 6 pi. Use the S to D button. Gives me 179.594 and so on. So to the nearest integer, 180. That's my answer to question 16. Question 17. Now, this question has a couple of tricks in it which come up now and again in the exams. So, a frustum is made by removing a small square-based pyramid from a similar large square-based pyramid as shown in the diagram. So you can see there's a big square-based pyramid. It's had its top cut off, and the top, which is being cut off, is a small square-based pyramid. The height of the small pyramid is 15, that's marked on the diagram. The height of the large pyramid is 45, that's marked on the diagram. The square base of the large pyramid has side length 39, that's marked on the diagram. Work out the total surface area of the frustum. Give your answer correct to the nearest whole number. Right, now let's first of all deal with the bottom of the frustum. The bottom is a square, measures 39 by 39, so I can find its area, 39 times 39. 1521. Now, let's think about the top. Here's the top. It's this square, isn't it? Now, I'm thinking that the height of the small pyramid is 1/3 of the height of the large pyramid. So this yellow length will be a third of the 39. So that square here isn't going to be 39 times 39, it's going to be 13 times 13, 169. Okay, so that is the top of the frustum and the base of the frustum, and I'm just left now with 4 sides. Now the 4 sides are all the same, and they are each a trapezium. Measures 39 there. Measures 13 there. And I need to find the area of that trapezium. Now, in order to find the area of a trapezium, I need to know its height. So I'm wondering how I'm going to find the height of the trapezium. And if I were to mark that height here, it would look like that. Okay. Now, with a square-based pyramid, it's often useful to find this length here, which I'm about to mark in green. It's often useful to find the length of that edge there, that green edge. Now, you're probably thinking, how on earth am I supposed to find that green edge length? Well, the answer is that you can make a right-angled triangle. And the right-angled triangle is made with the green edge and then with a perpendicular which is dropped from the top of the square-based pyramid to the middle of the square. And then the triangle is completed with a line along the base of the square-based pyramid. Now, that's a right angle in the corner there because it is the angle between a vertical line and a horizontal line. What about the lengths? What lengths do we know here? Well, you know the height of the whole of the square-based pyramid is 45. So you know that that line from the base, from the center of the base, all the way up to the apex of the pyramid is 45, because that's the height. Do you know this length, the length of the base of my triangle? Well, you do actually, because it is half of the whole diagonal. It's half of the whole diagonal there. Okay? So let's work out the whole of that diagonal there. Well, the whole of the diagonal there is the hypotenuse of a right-angled triangle. So the whole of the diagonal is the square root of 39 squared plus 39 squared, because it's the hypotenuse. That's the base there, measures 39 by 39. There's the diagonal line. Use Pythagoras. It is the square root of 39 squared plus 39 squared. Okay, which is 55.15. So therefore, the base of my right angle triangle is half of that. So the base of the triangle is that divided by 2. 27.577. So what I've got is I've got my green triangle. Its height is 45. Its base is 27.577. And now I can find the length of its hypotenuse, which happens to be the edge length of the square-based pyramid. So that is going to be the square root of 27.577 squared plus 45 squared. I happen to have 27.577 on my calculator already, so I'll square that. Plus 45 squared equals square root answer equals. So that hypotenuse is 52 0.7778. Okay. Now, how does that help me? You may well ask. Okay. I've just found the length of the whole of this edge there. Okay. That is related to this length here. That diagonal length on the trapezium is going to be 2/3 of the whole diagonal, because the top is 1/3 of the whole shape. So this bit here is 1/3 of the whole length, leaving 2/3 of the whole length for the diagonal of the trapezium. So that means that this diagonal here is 35.185. So now I can find the height of the trapezium. Let's draw out the trapezium a little more carefully and have a look at that. So here's my trapezium. Okay. Now, the diagonal length here is 35.185. This length is 13. This length is 39. Right, if I drop a perpendicular there, then I have got a length of 13 here, 13 in the middle, and 13 there. So my height here of the trapezium, which I call h, is the square root of 35.185 squared minus 13 squared. I've still got 35.185 on my calculator, so I'm going to square that, equals minus 169 equals square root answer equals. So the height is 32.6955. Now, finally, I can find the area of the trapezium. The area of the trapezium is the average width, so 13 plus 39 over 2, multiplied by the height, 32.6955. Okay, so that is 13 plus 39 is 52, isn't it? So that's 26 multiplied by the number on my calculator. So the area of the trapezium is 850.08. So my whole surface area then is going to be the area of the bottom, 1521. The area of the top, 169. And 4 850s.08. Okay, so times the 850.08 by 4, add 1521, and add 169, gives me 5,090 to the nearest whole number. And that is quite a question. No wonder it's a question number 23. Well done for working your way through those questions. If you'd like a hand, leave me a question in the comments. And if you found the film useful, please like the film, please share the film, please tell me so in the comments. Thanks for watching. See you in the next film.